this is Mr. Hughes. I am going to go through the Chapter 9 test solutions. Problem number 1, draw a net for the figure on the right. So here is our figure on the right. Want to go over a couple of things. These little hash marks say that all 3 sides have a length of 3 feet. And then my 2 is my slant height. All right, my net. There is many more than just one way to draw the net. This is the way that I'm going to choose to draw it because this is how I see it. But I've seen some others. You might even want to think about it as 3 triangles strung together, and there's one on the other side. That is also a net. So these are our solutions for number 1. If you come up with another one, absolutely, that works. You can have many more than just one solution for the slant, for the net of a pyramid. Okay, what is the slant height? Well, it's that too. It's the height from the base of the pyramid to the top along one of the faces. So my slant height is 2 feet. What is my lateral area? Well, lateral area is 1/2 perimeter times slant height. So what is my perimeter? I have 3 times 3, 3 plus 3 plus 3. So rewriting, I have a perimeter of 9 and a slant height of 2. My 2's cancel. So I get 9 feet squared. And then what is my surface area? If the area of the base is 3.89 square feet, what is the surface area? So it's telling me that this bottom is 3.89 feet squared. So my surface area is the lateral area plus the base area. And I already got my lateral area. It's 9. My base area, it tells me, is 3.89 feet squared. So that tells me my surface area is 12.89, 89, not 88, 89 feet squared. Okay. Up next, we want to find the surface area of each figure to the nearest whole number. So first I need to find what I have. Here is my slant height, and this is my diameter. I need my radius. My radius is 1/2 of my diameter, so it's 5 millimeters. One way to think about it is this piece is radius from here to here, but the whole thing is my diameter. So what's my surface area? It is the lateral area, once again, plus the base area. What is my lateral area? My lateral area is pi r times the slant height. Pi times r, what's my r? It's 5. What is my slant height? It is 11. So I get 55 pi. And then I can even round that. I'll round at the very end. What is my base area? My base area is pi r squared. So pi times 5 squared. So I get 25 pi. So what is my surface area? But 80 pi. That is 55 plus 25 is 80 pi millimeters squared, and that approximates as 251 millimeters squared. That's rounding to the whole number. Okay, we have the same thing going on over here in problem number 6, except I don't know my slant height. I need to know this. I need my L. What is it? Well, I can use the Pythagorean theorem. What is this dimension? Well, that's going to be 20 because that's half of my pyramid, half of the width of my pyramid. Okay. So that means I have 15 squared plus 20 squared equals L squared. And what's 15 squared plus 20 squared? Ends up being 625, and that's inches squared. And so my L is actually 25 inches. Okay, now I have that, I can find my lateral area. I'm going to play the same game again. I have my surface area is lateral area plus base. Lateral area is 1/2 perimeter times the slant height. And now I need to plug those in. What is my perimeter? So it's 40, 40, 40, 40. So it's 160 times my slant height of 25. So that gives me 125, or 160 times 25. I end up getting 2,000 inches squared. That's a pretty big number. Now, what's my base? My base area is going to be 40 by 40. So I get 40 squared, which is 1,600 inches squared. And so that gives me a surface area of 3,600 inches squared. Okay, now we have to find volume. Notice it's volume. So number 7, I need the volume is 1/3 base area times height. What is my base area? Well, it's the same same pyramid from the previous problem. Okay, so my base area is already done for me. It's 1,600 inches squared. My height, here's my height. This is my h. So my volume is 1/3 times 1,600 times 15. So plugging that into a calculator, I get 8,000 inches squared. Okay, the next problem is a cone. So we have a slightly different volume formula. It's 1/3 pi r squared h. So do we have r? Here's our r. Here's our h. Notice it's h, not L. L is a slant height. H is just the height. So I have everything I need to figure this out. I'm just going to plug in. I have 1/3 pi r, r squared, so it's 5 squared, r is 5, times 12. So I get 100 pi meters squared, or to the nearest whole number, even to the nearest tenth, using pi as 3.14, 314 meters squared. Here I am. I'm a bad teacher. I messed up my units. This is volume. These are volume units. So it's cubed. All right. Now my volume for number 9, it's a similar formula. It's going to be pi r squared times height. Not the 1/3, Notice the 1/3 here, no 1/3 here. So my volume is pi r squared. What's my r? Here's r. Here's my h. I have pi times 5 squared times 7. I get pi times 25 times 7, which is 175 pi inches cubed. And that's approximately 549.5 inches cubed. Okay, next one. This one, it looks a lot harder than it is. Well, here is the formula. So let's look at this. 1/3 pi r squared h. It is the same formula for the cone above us. So these are the same formulas. But what is h? H is literally the height from bottom to top of the cone. Even an oblique cone. So there's our h. And it's the same radius. So plugging everything in, pi times 6 squared times 20, which gives me 1/3 pi times 36/20, which is 240 pi, which is approximately 753.6 inches cubed. Okay, now let's go to the next problems. A container company makes small and large cylindrical shampoo containers. The area of the base of each cylinder is 10 centimeters squared. The volume of the small shampoo container is 60 centimeters cubed. The large shampoo container is 3 centimeters taller. What is the volume of the large shampoo container? So I really do think drawing a picture helps. So here is my small. And here is my larger container. Now, this might not be drawn to scale, but that's not what we're worried about. The area of the base is 10 centimeters squared. The area of the base is 10 centimeters squared. How much room can fit in this 3 centimeters of vertical height? Well, my volume is still the same thing. So it's base area times height. So my volume is going to be the 10 centimeters squared, 10 times the height of 3. So my volume is, this is the extra volume, 30 centimeters cubed. So my large shampoo container is 90 centimeters cubed, because this one was 60 centimeters cubed. So we only had to find out what was missing, because we already knew that they both shared the bottom. Here's the smaller container built into the bottom one, or into the larger one. Okay, so next problem, we're finding surface area and volume of each sphere. So surface area. Surface area for a sphere is 4 pi r squared. What is our r? Here is our r. 4 pi times 11 squared which gives us 4 pi times 121. So I get 484 pi inches cubed. Okay. Now let's see. That's also approximately. That is approximately 1,519.76 inches squared. Okay, now our volume. Our volume is 4/3 pi r cubed. And our r is still 11. So I'm going to have 4/3 pi times 11 cubed. So pi r, not r. We've already substituted 11 for r. So I get 1,331. Forgot my 4/3 up front. And this is equal to 5,324 pi inches cubed, or we can approximate it as 5,572.45 inches cubed. Okay. In this next problem, we're given the diameter. So this is our diameter. That means our radius is half of our diameter. That's 2.5 centimeters. Okay. So what is our surface area? We use the same relationship, 4 pi r squared, which is 4 pi times 2.5 squared. 4 pi times 2.5 squared. 2.5 squared is 25/4. That's centimeters squared. So that gives us 25 pi centimeters squared. Now our volume, oh, I didn't give our approximation. So it's also approximately 78.5 centimeters squared. Our volume still follows the same relationship, 4/3 pi r cubed, which gives us 4/3 pi times 2.5 cubed. And here we get 500 thirds. Ooh, 524ths. Terribly sorry. 24ths, because this is the same as 5 halves. And 500 pi centimeters cubed, which is approximately equal to 65.41 centimeters cubed. Okay. The next problem, the circumference of a standard bowling ball is about 27 inches. To the nearest unit, how many square inches is the surface area of 100 bowling balls? First off, we have to find the surface area of one bowling ball. So how do we find that? So I'm going to start by writing my equation. Surface area is 4 pi r squared. I don't know r. I need this. But I have something that'll tell me what my r is. So if I go to my circumference is 2 pi r, which is also 27 inches, which tells me that r equals 27 divided by 2 pi. Now, I got that. Let's look at that for just one moment. So I have 2 pi r equals 27. Well, I want to divide both sides by 2 pi to isolate the r. 2 pi. 2 pi divided by 2 pi is 1. So my r equals 27 over 2 pi. Okay. So we found this. You can approximate it. I didn't. I went ahead and I substituted. So I did my surface area equals 4 pi. Then I substitute my r, which is 27 over 2 pi. Remember, you can approximate it. And then that is 1 bowling ball. That's 1 bowling ball. And we want to know 100. So 100 times the surface area gives me 72,900 over pi square inches. That's really hard to visualize, but we'll approximate it. 23,216 inches squared. Okay, now let's look at this error. Your friend draws a net of the prism. What is your friend's error? If I fold this up, this side and this side will match. This side and this side will match. This side and this side will match. And this side and this side will match. Well, these sides will match. Here's our problem. The bottom, these don't have a base to attach to. So what's our friend's error? Our friend forgot the base. And of course I wrote in an incomplete sentence. So here, let me fix that. Our friend forgot the base. Compare and contrast. How are the formulas for surface area of a prism and surface area of a cylinder alike? Well, let's see. We look at cylinder, prism. Surface area is 2 bases plus 2 pi r h, and then the prism is 2b plus p h. P is the perimeter. So how are they similar? There are 2 bases. These are similarities. And then my lateral area, the lateral area is different. Those are 2, that's 1 similarity and 1 difference. Different people saw different things, because if I decided to write out my base for a cylinder, I get pi r squared. And then my base for a prism is length times width. Okay. So there's more than just these 2 similarities and differences. A cylinder has a height of 5 millimeters and a volume of 800 millimeters cubed. What is the radius of the base to the nearest tenth? Well, what do we know? I know my volume, that is 80 millimeters cubed. And I also know the relationship for my volume, that is the base area times the height. And then I know my height, and that is 5 millimeters. So what is the formula for the volume? It's the base area, and the base area is pi r squared times the height. So plugging in some numbers, my volume is 80 pi r squared times the height of 5 millimeters. So divide both sides by 5 pi. Then I have r squared equals 80 over 5 pi. And then I need to take the square root. 80 over 5 pi. And that is approximately 2.2 millimeters. And that is how we find the radius of the base to the nearest tenth.